Hello everyone, and welcome to the first Science Café of 2015. As you know, we have a very fantastic beginning of our Science Café, and we have here Esko Valtaoja, who will talk about life in the universe.
Good evening everybody, nice to be here. Okay, for the next half an hour I will talk first. As Sabrina said, you are free to interrupt me if you can. I'm not very easy to interrupt when I can really get into high gear, but please try. And then of course afterward I will be more silent and it's easier to ask. But anytime, as Sabrina said, if you feel like asking something, protesting, so do it. So life in the universe, where to start? I have not, in the spirit of this, I don't have any transparency that would remind me what I'm going to say, and I don't really have any idea what I'm going to say because I didn't make any manuscript. So where to start? Let's start that I will prove that there is life in the universe, that the universe is full of life. So that's the part one. What have we learned about the universe during, let's say, the 400 years since our modern age started 1609, Kepler, Galilei? We started to have an understanding of the universe we are living in, planets, stars, the whole thing, also the rules, the laws of nature that, as we now know, are the same everywhere, anytime. To make a long story short, we know now our own galaxy, the Milky Way. There are maybe 400 billion stars, let's say 100 billion roughly, just an order of magnitude. And with the Hubble Space Telescope we can see roughly 100 billion stars, galaxies. And we do know that is just a tiny part of the total universe. Some suspect that the universe is really physically infinite. Others that it's just much larger than we can see, much larger than the tiny area from which light has had time to reach us. But let's say 100 billion stars times 100 billion galaxies, that is 1 and 22 zeros. That is sort of like a number of grains of sand on all the beaches here on Earth. And one of these grains is our sun, and around it is a mote of dust that we call Earth, and that's the only place where we know that there is life. So this is the basic number, the basic fact we can start from. The universe, even if it would not be infinite, it's a very, very big place, much bigger than we really can realize. I mean, I cannot imagine 1 followed by 22 zeros. I don't even know the name of that number. It would be something billion, quadrillion or something. Yeah. But anyway, that's the number of stars. Other planets. Or what do we know about our own sun? That is something that we have become quite certain about, let's say during my lifetime, a little bit more. We know the history of the universe. We know that it's a bit less than 14 billion years old. We know how stars are born, how long they live. Like in the case of our own sun, we know that it still has about 5 billion years of life left. It will start aging, getting hotter, will burn away the Earth in a couple of billion years. We know the history of the universe, we know the birth, lifetime and death of stars. And what we have learned is that the sun is a totally ordinary star. There is something, there was a PhD dissertation just a few months ago where a student had been searching for analogues of Earth, stars that are, sun, stars that are absolutely similar to our sun. There are plenty of stars that are almost similar, other stars are maybe a bit dissimilar, but we can say that the sun is a perfectly ordinary run-of-the-mill star. We have not found anything special in its birth, its properties, its life. What about the Earth? For a long time there was the assumption that there are planets around other stars. It was because the most popular theory for the birth of the sun and planets was kind of nebular hypothesis, where gas and dust collapses under its own weight, gravitational collapse. It does not lead into a black hole, but it leads into a sun, and the remnants around it form planets. And now we know that this theory, there was also alternative theories that would have made planets extremely rare, maybe that even our solar system might have been unique in the whole galaxy. Now we know that those theories were not correct. We know it most of all because during the last 20 years we have started finding exoplanets, planets around other stars. There are, let's say, between 1,000 and 4,000 of them known now, a bit more than 1,000 confirmed, 3,000-4,000 that are very likely all are planets. There's a race on to find now not a solar analog but an Earth analog, a planet that is just with the same distance in the suitable zone, so suitable distance from the Sun. It orbits so that we know we can estimate the surface temperature of that planet. It's between 0 and 100 degrees centigrade, so that there is liquid water on it. We can estimate the sizes, the masses of the planets. We are now starting to find planets that are as small as the Earth. So we have not yet found a second Earth, even if there have been such a bit preliminary announcement, premature announcements in the media every now and then. But it will probably take only a couple of years. We can say, okay, there is that point of light. Now we know that around that there are planets, and one of those planets appears to be just like our Earth. So, ordinary sun, ordinary star, ordinary planetary system, ordinary planets. The most popular estimate is that there might be about as many Earth-like planets in our galaxy as there are stars. So 100 billion Earths. Nothing special in the history of our Earth, except for this one thing, that there's life here. And then of course, by analog, if there's nothing special here, why should life be something special either? So it's just a small jump of faith to claim that okay, there where there are planets, there's also life. If there's nothing special in Earth's conditions, why should there be any special in the fact that life appeared here on Earth? Given we don't know how life got started, it's possible we will never find out the exact mechanism because there are no fossils, no remnants, and there are several possible ways that we can imagine how a very complex molecule, more and more complex molecules start to build up until we have a molecule complex enough that it makes a copy of itself, and there we have the first Eve, the first common ancestor of our all, us, and including also the small bacteria in our guts. We are all related, closely related, as you know. So there must be life everywhere in the universe. The 100 billion Earth-like planets in our galaxy, the 100 billion other galaxies, it's totally impossible that we are alone. Case closed. Well, okay. That took 10 minutes. Now I will use the next 10 minutes to prove that there is no life anywhere else in the universe. Life is an extremely complicated phenomenon if you ask a biologist and not an astronomer. The astronomers tend to take life as given, but biologists and evolutionary biologists, paleontologists have a very different view. They point out the incredible number of accidents, random happenings, asteroid collisions, tectonic plates, and so on. Everything must be just so that the life as we know here on Earth can have been developed. There have been Gallup polls. You ask biologists how likely is it that there's life elsewhere in the universe, they are much less optimistic than astronomers would be. But of course that doesn't prove anything, just a reminder that life may not be as simple given phenomena, that the birth of life may be something totally different from the birth of suns or the birth and formation of planets. And we have been searching for that life in the universe. And we have found nothing at all. That is known as the Fermi paradox. According to the true story of the great physicist Enrico Fermi, who, as the story goes, they were sitting around a lunch table, somebody mentioned the idea that there might be life somewhere else in the universe. Enrico Fermi, in a typical Italian style, looked around. Where are they? And that's the key question. Where the hell are they? Because this is how Enrico's argument went, and it has been refined. You can put it in several ways. If this, what I said previously, is true, there's life everywhere in the universe, there should be also intelligent life here and there. Travel between solar systems, stars is possible. Even we have been making plans, engineers during their free time, how to build a nuclear fusion powered rocket, a space ark with which we could reach other solar systems. Of course they are light years away, of course the time even for light takes 4 years just to reach the nearest stars, but it is not impossible. Even with our limited technology, remember our industrial revolution, our science is only 400 years old. We as a species are 200,000 years old. It's just a blink of eye compared to the age of the Earth or the age of the universe. So the travel between stars is possible, not for us, not yet, but how soon? My sort of tongue-in-cheek guess that I made some years ago in the Tiede magazine is that around the year 2700 and something we will reach the nearest stars, the nearest exoplanets. That seems to be a reasonable extrapolation of the science we have right now. And we think of this other civilization, other planets. We know that Earth is quite a young planet, that is a fact. Most planets, most stars in our galaxy are older, let's say on the average a couple of billion years older than our Sun. And so also the planets are older there. So if there's life, the life has had much more time, let's say on the average again 2 billion years more time to evolve, 2 billion years more to develop intelligence, to build better rockets. So where are they? Why are they not here? Well, of course, Raunilena Luukanen-Kielde and Johanna Grant would say that they are here, they meet them every day, but I think that most of the rest of us would agree that they really are not here, and they have not even visited us in the distance. There have been no black monoliths found on the far side of the moon, no signs in ancient rocks, nothing like that. They all have been quite seriously also searched for. Nothing in, let's say, the Lagrange point, where sort of the triangle between the Earth, the Moon, and then a third point, the Lagrange point. You put something there, it stays there for millions and millions of years. Is there something, a message, a spaceship, a sentinel? No, nothing. So where are they? If life is life is common in universe, Fermi's paradox, why isn't anybody here? Why hasn't anybody been here? And also, if they don't visit, why are they not sending messages? Even we have for decades, we have a capability of sending messages tens of thousands of light years. We could even reach the Andromeda galaxy if we would use a little bit more power to send, hey, here we are, here is our message. Hello universe, which by the way I have done also, nobody answers. We have been, for the last 50 plus years, we have been listening to the stars, using the biggest telescopes we have, the finest computers. Is there any whisper, any artificial signal there? Nothing. The great silence, as it has been called. Fermi's paradox, which proves that there is no life anywhere else in the universe. We are alone. There have been answers, attempted answers to Fermi's paradox. I recommend to you all, there's a very nice book that also was translated into Finnish a few years ago. That exactly, there was 50 answers. That's just a tiny fraction of the possible answers. But none of these answers seems to be valid in the sense that they cannot explain why nobody ever has started to spread out. Why no civilization has started spreading out over the galaxy. Because once the spreading started, it's impossible to stop. So, Fermi's paradox, the great silence, we really are alone because there's no sign of anybody else. So now I have proven that we are alone and proven that we are not alone. Where do we go from here? We go to astrobiology. New science, even the name was coined only something like 15 years ago. There's astrobiology, European Astrobiology Association. There are big global conferences every 2 or 3 years. There's research, astrobiological research, even in Turku University. I and a couple of other astronomers, Harri Lehto and his biologist wife Kirsi Lehto and another biologist Esa Tyysjärvi, we started astrobiological research, teaching it at the university, the science of trying to find, understanding life as a phenomenon, not just listening to the stars, but trying to understand life as a part, as a cosmic phenomenon, and also, of course, trying to find life. Because my first 2 arguments, I was using facts, plain facts as we know them now after a lot of research, but I was using arguments, I was waving hands. Okay, this and this and this proves that this must be this way. Now that's the way we do it in philosophy, on theology, but if it's to be science, at the end of the day, we must do experiments, we must have facts, results, and that is what astrobiology is after. In numerous ways, we try to increase our meager number of facts so that we don't just have to wave hands and use fancy arguments, but we can really decide if there is life elsewhere in the universe. Of course, the great goal is to actually find it, get a message from the stars, hello, why don't you answer, here is the galactic encyclopedia, here is the message from the one true galactic God, or we find life on some other means. Of course, the nearest, most concrete way to start is to go and see if there is anything there. We have reached the moon so far, but nobody really expected there would be life on the moon, even if the Apollo astronauts were put in a 2-week quarantine just to be certain when they return to the Earth. Next nearest place, Mars. We have learned during the last 20-30 years with this armada of different satellites, landers, orbiters. We are starting to understand the history of Mars, the fact that it was wet, it was just like our Earth 4 billion years ago, around the time life started here on Earth. So did it start also on Mars? If life is a common universal phenomenon, it should have gotten started also on Mars. If not, well, then we know that, okay, of the 2 planets we have so far researched, only 50% have given birth to life. It's a start, but it still doesn't tell that if the probability is closer to 1/2 or 0, but it's still a beginning. Of course, the great hope is that we find life on Mars, maybe still living there deep in the bedrock, in the permafrost, just like the permafrost in Siberia. There's plenty of water on Mars, just not on the surface, because none of Earth bacteria could survive on Mars, on the surface of Mars. But dig a hole, drop some suitable bacteria in there, they would be perfectly happy to live there on Mars. Maybe there's life that started on Mars, life became impossible as conditions worsened on the surface, but there's still life deep down there. Or maybe there are fossils, if no present, extant life. The final way to find it out, of course, is to send astronauts to Mars. The year 2030 has been bandied. Now the people are talking more serious about 2040. If you would really use a bit of money or make it a sort of a Big Brother kind of show, so we could do it in 10 years. It's not so much question of technology, it's more question of money. To find money to send people to Mars. Or maybe even our robotic landers will find life there. There are incremental plans. The landers, the Mars crawlers there nowadays, they are mainly just studying the geology of Mars. They have not been built to find life there, but time for that will also come, hopefully during my lifetime. What else can we do? Concrete evidence of life. If we exclude what we of course are also trying to do, building bigger dedicated telescope arrays so we can really listen to the universe, the stars, millions of stars, for any whispers of intelligent activity. That's the second thing. That's a bit of a long shot, but it's worth trying. Third one is we build bigger space telescopes, in fact an armada of space telescopes, such are on the drawing board already, called Darwin, European Space Agency. An armada of space telescopes, we don't send them to the stars, that would take tens of thousands of years, but they will create, by a thing called optical interferometry, they will imitate an optical telescope size of kilometers, maybe even tens of kilometers, depending on how rapidly our technology advances. With such an armada of space telescopes, we can not just detect exoplanets that we can do now, but really take images of these exoplanets, study their atmospheres, see if there's water vapor in the atmosphere, is there ozone there, is there methane there, are there clear signs of organic activity. We can, let's put the mark 20 years from here, we should have these telescopes, these plans should have been fulfilled. Again, it's a question of not technology but money, like all our space plans. So in 20 years of time, we can study these exoplanets, these thousands of exoplanets, and say if there's life there. So we are getting really close. How much time I have spent? I have 5 minutes left. What else could we do? Of course, we can have arguments, wave hands and so on, back and forth, which is of course what astrobiologists also do. Maybe the final important thing is that we study more closely life here on Earth and try to understand its beginnings, because that would also give us a clue how likely a phenomenon it is. You can do it from the bottom down. A famous experiment by Miller and Urey already 60 years ago. You put some organic but non-living materials into a jar, you put energy in there, you heat it, electric shocks, whatever, and see how more and more complex molecules build up. And the idea is that by continuing that long enough, you would get an organic molecule complex enough to copy itself. Or you can do designer molecules, self-replicating molecules. They are important also when you try to do things like new medicines, self-replicating molecules that might be precursors of life. Or you can do not from bottom up, but from top down. You take the simplest living things that we have nowadays that have only a few hundred genes. You start picking away these genes, seeing how simple a living thing can be and still be living. And that way we hope that we can find out what the first common ancestor, the Eve, looked like, and that would give us a better handle, a better understanding of how life got started, or at least what is the possibility, the likelihood. Because there are some people, biologists, who say that life in itself, it's an impossible accident. They are not crackpots, they are not religious fanatics, even though there are also such people, but they include, for example, Sir Francis Crick, the co-discoverer of double helix, our DNA, who at least used to favor the idea that life has been transported here from somewhere else. We don't know. I'm not a specialist there. To me and most biologists also, specialists, it seems unlikely that it's really a totally impossible happening that life starts all by itself without, let's say, God's hand there, or space aliens coming here and polluting our pristine planet. But we don't know. And of course, at the end of the day, whatever arguments we use for or against life here on Earth, as long as we only have one example, it's not really enough, because you cannot do statistics with one data points. So, however likely or unlikely life here, the beginning of life just by itself seems, it can never be certain before we have really reached, if not our hands and rockets and astronauts, so with our space telescope, optical interferometry, whatever, we have studied these exoplanets, as I said, let's say 20 years time. I plan to stay alive at least that long. I hope to see astronauts on Mars also, so that I will finally know the answer to David Bowie's question, is there life on Mars? Because then also, and only then, we will start to understand what really is, what is a human being? The basic question that always has been asked. Darwin changed everything, gave a totally different answer. What is a human being? You cannot understand it with us without evolution, but you cannot understand evolution without knowing the cosmic content, cosmic evolution. Did it happen only here? Did it happen everywhere? Are we, as Douglas Adams said, mostly harmless, or are we really the kings of the empty, lifeless, infinite universe? That's my half an hour, so now it's your turn. Thank you.